Hello everyone. In this video we'll talk about similarity, which will make us to understand the distance-based algorithms like k nearest neighbor, k means easily. We'll take one example. So let's say we have 10 students in the class and we want to find which students are similar to each other. So to find the similarity, we have few attributes like height, color, marks scored by each subject, or overall score, and so on. We have many different attributes to find the similarities, right? So obviously based on these attributes I can say student A and B are similar to each other, but there is a problem, right? Not two students will be at the same height, will be at the same weight, they won't score the same marks. Now how can I find the similarity? That's where the distance matrix comes into the place. So what we'll do is we'll take one simple example, right? So let me open my Excel sheet, right? So we have three students details. One is Vishwa, who scores 10 marks, Teja, who scores 9 marks, and Satish, who scores 5 marks. This guy Satish is always, the bad student in the class anyways, so that's why he scored less marks. Okay, now we'll calculate the distance between Vishwa and Teja, right? So if you calculate the distance between Vishwa and Teja, it would be 10 minus 9 would be 1, right? Between Vishwa and Teja, I'll write it here, Vishwa, Teja, right? So the distance is 1. Now I'll find the difference between Vishwa and Satish. Would be 10 minus 5. Come on. 10 minus 5 is 5. See, that's how Satish works. Come on, let me write 5, right? And then between Teja and Satish, it would be 9 minus 6, it's 3. Come on, Satish. Yep. Okay, let me, yep. Now if you see, right, the difference between Vishwa and Teja is very less, which is 1, compared to Satish, right? So in our case we can say Vishwa and Teja is similar in nature in terms of their scores. This is called, this difference is called the distance, right? Now with the help of distance I can conclude Vishwa and Teja are similar, right, based on their scores, whatever. Right? Now where do we use this distance metrics, right? There are two major use cases to find the similarities, to identify the similarities. I mean, when you say similarities, we usually go with the distance metrics, right? One of the widely used use case in statistics is to find the similarities between the groups, right? So if you remember, we already talked about the correlation. It's nothing but a Pearson correlation, right? It will tell you between the two variables how much it is traveling to each other together, right? In the similar way we have Kendall correlation, Pearman correlation, chi-square, ANOVA, t-student test, which anyways this remaining we are going to discuss in our further videos. But if you see correlation, this is obviously uses the distance matrix, right? It will tell you how two variables are traveling together, whether they are traveling together nearby or far, right? So something like that we can conclude, right? Let's say if the correlation is 1, we can say both variables are traveling together nearly. If it is 0, there is no relation between two variables, right? Like there is no relation between Vishwa and Satish because the distance is too far, right? Now coming to our machine learning, right? In case of supervised learning, we do have similar problems, right? Mainly in classification world, right? If you want to find the person who will be the defaulter in this month, we'll check the person with his closest person who is similar to him and will decide if he's going to be default or not based on the similarity of the person, right? So one of the widely majorly used algorithms in the distance based technique is k nearest neighbor, which also called KNN, right? So what we'll do is, maybe in our next video we'll talk about KNN algorithm, how to calculate it, how to derive it, right? So hope you enjoyed this video. Please don't forget to subscribe my channel. Thank you.